Hi, this is Margo. This is Saturday, July 21st, 2018, and today we're going to be talking about Antarctica. I've been wanting to put together a show just talking about the background of Antarctica and how it's made up, and about the glaciers down there and the sea ice and things like that, because we focus a lot on the Arctic and the Arctic sea ice melting and everything, but we don't give very much attention to the Antarctic. And recently it has come in the news because they're saying the Antarctic sea ice and the glaciers are melting really fast, and I've got a lot of information to share today. And what we're looking at first is just a map of Antarctica, which is the South Pole. So it's at the bottom of the globe. Here's the South Pole, and it's divided into two parts. We have the East Antarctica on the right and the West Antarctica on the left. And then this is an archipelago or peninsula up here on the western side, which is an easy way to figure out your orientation, because sometimes when you see these pictures of the Antarctic, it'll be backwards, because that's just the way they do it. I know on Climate Reanalyzer, when you look at the Antarctic, it's flipped so that this peninsula is over here, but this tail down here is South America, just so you get your bearings here. So we're going to be looking at the Antarctic today, and first of all, before we get started into it, there is a new Facebook group that Robin Westenra created last night, if anyone's interested, and it's called Climate Change in the Antarctic. And he and I were messaging, and we were talking about the concentration of the sea ice down there and how it's in the middle of winter and it seems like it should be more and this and that. And apparently he's been doing a lot of research about the Antarctic for several years and has it on his blog. And so as a result of us talking about this, he started this group last night, and so it's an open public group. I'm a member, he's a member, and there are a few members so far. So he's posted a lot of links of his research already. So if you want a crash course on what's going on in the Antarctic, about how it's melting faster than they expected, and he's got lots of links to articles. They're melting 3 times as fast as a decade ago from the New York Times. And here's Washington Post. Antarctica's penguins could be decimated by climate change. And then this was from November, where they said an Antarctic supervolcano melting ice sheet from within. And this was from RT.com. And then these are posts from his blog. He's got lots of information on his blog, and he lives in New Zealand, so this information is close to his heart because he's right down there close to the Antarctic. And here's from June 2017. Scientists stunned by Antarctic rainfall and a melt area bigger than Texas. It's not supposed to rain down there. So, an Arctic heat spasm that created the beast from the east has southern counterpoint. Here's another one. Underwater melting of Antarctic ice far greater than thought, study finds. This is a really good blog post that he put up, and he talks all about how the base of the ice is melting because the water coming up underneath is warmer than normal, and so it's melting. And here's he has links to radio shows from New Zealand about the Antarctic sea ice. So I encourage you, and here's a recent article. Study now puts Antarctica in the frame of one of the largest contributors to sea level rise. So this is no joke. And here's another one. Antarctic ice melt faster than previously expected. So, like I said, this is no joke. And what I've noticed in just watching news and watching things that happen is, you know, when we focus on one area, like when we're so focused on one area like the Arctic, with the Arctic sea ice melting, then things can be going on in a different area that can be really important for us to know about, but we're not looking there. It's like a magician's trick. You know, a magician that's up on stage and he's drawing your attention in a certain way, but the magic happens behind the scenes, or it could be even right in front of your eyes, but you're just not watching, you're not focusing there. And so this is kind of my thought, that we need to really be looking at these things and be focusing on all aspects of abrupt climate change, because this is important, and this information about the Antarctic there hasn't been a lot of information about it because they just didn't have access down there. But you're going to see that a lot of countries have science stations down there, observatories and things like that, and so they've been studying all this stuff for a long time. So I think it's time that we really look at these things. And you know, I encourage you, go to I'll leave the link to the new Facebook group in the description of the video below, and I'll leave a link to Robin's blog. It's called See More Rocks, but it's robinwestinra.blogspot.com. So he's got tons of research on the Antarctic. I mean, this is such a treasure chest here, and we're going to be following the Antarctic. Now they're in their winter season right now, so while the northern hemisphere is in summer, they're in their winter. So the sea ice is building back. It's building back. So we're going to talk about the seasons down there and a whole bunch of stuff in this show today. So this is not a climate cast update. This is focused on Antarctica and giving you a background. And let's see if everything's going to cooperate for me today. Okay, we're going to start with Wikipedia because it's very easy to understand. Here's a picture that, like what we saw, Antarctica is Earth's southernmost continent. It contains the geographic South Pole and is situated in the Antarctic region of the southern hemisphere, almost entirely south of the Antarctic Circle, and is surrounded by the Southern Ocean. At 14 million square kilometers, or 5,400,000 square miles. It is the fifth largest continent. For comparison, Antarctic is nearly twice the size of Australia. About 98% of Antarctica is covered by ice that averages 1.9 kilometers or 1.2 miles or 6,200 feet in thickness, which extends to all but the northernmost reaches of the Antarctic Peninsula. That's the peninsula there that I was telling you about. Now let's see, now my computer's acting up now that I'm recording this. It's been fine all day. So let's just hope we can get through this. Antarctica on average is the coldest, driest, and windiest continent and has the highest average elevation of all the continents. Antarctica is a desert with annual precipitation of only 200 millimeters or 8 inches along the coast and far less inland. Okay, I tell you what I'm going to do. I'm going to get rid of these tabs as I use them. Maybe that'll help. The temperature in Antarctica has reached minus 89.2 degrees centigrade or Celsius, or minus 128.6 degrees Fahrenheit, or even minus 94.7 degrees Celsius as measured from space, though the average for the third quarter, the coldest part of the year, is minus 63 degrees Celsius and minus 81 degrees Fahrenheit. Anywhere from 1,000 to 5,000 people reside throughout the year at research stations scattered across the continent. Organisms native to Antarctica include many types of algae, bacteria, fungi, plants, protista, and certain animals such as mites, nematodes, penguins, seals, and tardigrades. Vegetation where it occurs is tundra. Although myths and speculation about a Terra Australis or southern land date back to antiquity, Antarctica is noted as the last region on Earth in recorded history to be discovered, unseen until 1820 when the Russian expedition of Fabian Gottlieb von Bellinghausen and Mikhail Lazarev on Vostok and Mirny sighted the Fimbul ice shelf. The continent, however, remained largely neglected for the rest of the 19th century because of its hostile environment, lack of easily accessible resources, and isolation. In 1895, the first confirmed landing was conducted by a team of Norwegians. Antarctica is a de facto condominium governed by parties to the Antarctic Treaty System that have consulting status. 12 countries signed the Antarctic Treaty in 1959, and 38 have signed it since then. The treaty prohibits military activities and mineral mining, prohibits nuclear explosions and nuclear waste deposit, supports scientific research, and protects the continent's ecozone. Ongoing experiments are conducted by more than 4,000 scientists from many nations. And the treaty, I'm going to show you that in a minute, but the treaty is open for review in 2048. So that's not very far off, and I think they're just like biding their time until 2048 before they go down there and start tearing up the Antarctic. Anyway, you can read about this. So it's basically desert in the middle. Here's all the different expeditions that went down there. Here's the geography. Positioned asymmetrically around the South Pole and largely south of the Antarctic Circle. Antarctica is the southernmost continent and is surrounded by the Southern Ocean. Alternatively, it may be considered to be surrounded by the Southern Pacific, Atlantic, and Indian Oceans, or by the southern waters of the World Ocean. There are a number of rivers and lakes in Antarctica, the longest river being the Onyx. The largest lake, Vostok, is one of the largest subglacial lakes in the world. So let's look at this map. This is pretty cool. So let's zoom in. And so you can see the east, and then it's kind of natural division here, and then the west, and here's the peninsula. Now, an area of interest that we're going to be looking at is right here. And this is the where the Pine Island Glacier is. And that's melting really fast. And they have found or suspect that there's an active volcano underneath that glacier that's causing it to warm so fast. Now this is the Ross Sea down here. This is another area that you'll hear a lot about. This is the Ross Ice Shelf. There's a little island right down here, the Ross Island, which houses Mount Erebus, which is an active volcano that stands at 12,448 feet. And this right up here is the Larsen Ice Shelf, and so I was surprised when I saw how small that Larsen Ice Shelf is compared to these other ice shelves and the sea ice and different things. I remember like last year and a few years ago, the Larsen Ice Shelf started breaking off because it had warmed up so much, and you know, scientists were up in arms, and they said these huge chunks as big as Delaware in different states were floating around, and well, that was off of this Larsen Ice Shelf. So it's still there, it's diminishing as well. So you want to remember the Ross Ice Shelf, and that's at the bottom and is part of the Ross Sea. And you want to remember the Pine Island Glacier down here on the west side of Antarctica, and you want to remember the Antarctic Peninsula, which is on the west side, and the east side is melting slower than the west side. So that's a really good map to look at. And remember the Weddell Sea. That's important because there are several different glaciers. They call them lake streams, I think. We'll look at that in a minute. Ice streams. And these glaciers, as they melt, they feed into these seas. And this is fresh water that's feeding into the ocean. And that fresh and coming off of the land like that, it can contribute and will contribute to global sea level rise because it's not already part of the ocean. So let's go back down here. Let's find where we were. Okay, I'm going to pause. I need a sip of my tea. I'll be right back. Okay. Antarctica is divided in two by the Transantarctic Mountains close to the neck between the Ross Sea and the Weddell Sea. That's these mountains. The portion west of the Weddell Sea and east of the Ross Sea is called West Antarctica. That's this side. And the remainder, East Antarctica, because they roughly correspond to the western and eastern hemispheres relative to the Greenwich meridian. About 98% of Antarctica is covered by the Antarctic ice sheet, a sheet of ice averaging at least 1.6 kilometers and 1 mile thick. The continent has about 90% of the world's ice, and thereby about 70% of the world's fresh water. If all of this ice were melted, sea levels would rise about 60 meters or 200 feet. In most of the interior of the continent, precipitation is very low, down to 20 millimeters or 0.8 inches per year. In a few blue ice areas, precipitation is lower than mass loss by sublimation, and so the local mass balance is negative. In the dry valleys, the same effect occurs over a rock base, leading to a desiccated landscape. So let's look at this. I love looking at maps. So here's the mountain range that they're talking about. Right there. Alright, West Antarctica is covered by the West Antarctic ice sheet. The sheet has been of recent concern because of the real, if small, possibility of its collapse. If the sheet were to break down, ocean levels would rise by several meters in a relatively geologically short period of time, perhaps a matter of centuries. Several Antarctic ice streams, that's what they call it, ice streams, which account for about 10% of the ice sheet, flow to one of the many Antarctic ice shelves. See ice sheet dynamics. So they call the glaciers ice streams. So I'm going to show you. Okay. East Antarctica lies on the Indian Ocean side of the Transantarctic Mountains and comprises Coates Land, Queen Maud Land, Enderby Land, Mac Robertson Land, Wilkes Land, and Victoria Land. All but a small portion of the region lies within the East Hemisphere. East Antarctica is largely covered by the East Antarctic ice sheet. Vinson Massif, the highest peak in Antarctica at 4,892 meters or 16,050 feet, is located in the Ellsworth Mountains. Antarctica contains many other mountains on both the main continent and the surrounding islands. Mount Erebus on Ross Island is the world's southernmost active volcano. Another well-known volcano is found on Deception Island, which is famous for a giant eruption in 1970. Minor eruptions are frequent, and lava flow has been observed in recent years. Other dormant volcanoes may potentially be active. In 2004, a potentially active underwater volcano was found in the Antarctic Peninsula by American and Canadian researchers. So they've got lakes, they've got mountains, they've got rivers, they've got volcanoes. I mean, it's an active place. You wouldn't know it. You would just think it's all frozen down there. But there's a lot going on under that ice. And anyway, it goes through the history and then present day. They use remote sensing, ground-penetrating radar, and satellite imagery to begin to reveal the structures beneath the ice. Geologically, West Antarctica closely resembles the Andes mountain range of South America. The Antarctic Peninsula was formed by uplift and metamorphism of seabed sediments during the late Paleozoic and early Mesozoic eras. This sediment uplift was accompanied by igneous intrusions and volcanism. So, here's your climate. It's the coldest continent. It used to be ice-free until about 34 million years ago, when it became covered with ice. And there are certain penguins that live down there. The population. Oh, I'll show you that in a minute. Several governments maintain manned research stations on the continent. And there are about 1,000 people in the wintertime and up to 5,000 in the summer who conduct scientific experiments. Biodiversity, here's the animals. The emperor penguins in the Ross Sea from Antarctica. It's the only place they live. There's phytoplankton down there. Fungi, plants, other organisms, conservation. Now, here are the politics. Several countries claim sovereignty in certain regions. While a few of these countries have mutually recognized each other's claims, the validity of these claims is not recognized universally. New claims on Antarctica have been suspended since 1959. Although in 2015 Norway formally defined Queen Maud Land as including the unclaimed area between it and the South Pole. So, anyway, here are the territories of Antarctica and who kind of rules over these territories. Here's this started by date: the United Kingdom, 1908, British Antarctic Territory, and it's this little area surrounding the Weddell Sea. 1923, New Zealand, and that's called the Ross Dependency. It's down here, off of the edge of the Ross Sea. 1924, France claimed this little sliver. 1929, Norway claimed this island. I'm not sure what that island. Oh, Peter Island. 1933, Australia claimed a large area of the East Antarctica. As you can see, it claims most of it, Australia, and that's the Australian Antarctic Territory. 1939, Norway claimed a lot of the northern part. 1940, Chile claimed this part on the southern part of the Weddell Sea. 1943, Argentina claimed some more parts around the Weddell Sea. And then there is a large unclaimed territory on the west side, which is called Unclaimed Territory, and they call that Marie Byrd Land. And we're going to look at that because this is the area where the Pine Island Glacier is located, and so it's interesting that that's in the unclaimed territory. So I don't know who kind of looks at over that area or whatever. So here's the economy, research. They found meteorites down there, ice mass and global sea level, effects of global warming. They're saying that it is warming. It says some of Antarctica has been warming up. Particularly strong warming has been noted on the Antarctic Peninsula over on this west side. And see, that's where that Pine Island Glacier is, where they found the volcanoes underneath. A study by Eric Stieg, published in 2009, noticed for the first time that the continent-wide average surface temperature trend of Antarctic is slightly positive at greater than 0.05 centigrades or Celsius or 0.09 Fahrenheit per decade from 1957 to 2006. And it's warming faster since then. And the ozone hole, we talked about that. I did a show about the ozone hole. And it's bigger in the winter time because ozone is depleted in the winter and comes back in the summer. So I'll leave the link below to that. Now, I've got another picture. The next picture I want to show you. These are the glaciers. Or the river streams that they talk about. This is the Pine Island Glacier right here. That's the one that's melting so fast. It's this whole area, but you can see, and it flows out. And then there's an ice shelf that it adds to and goes into. There's another one here. And so if this Pine Island is melting fast, then probably this one, I can't hardly see that. The Thwaitos Glacier is probably melting faster too. So that's probably something we're going to need to keep an eye on. And then there's a few over here on the edge of the Ross Sea. So there's that. Now we're going to look at the seasons in Antarctica. They basically have two seasons, winter and summer. And it's the coldest place with the biggest desert on Earth. Severity of its climate is caused by a number of factors. First is altitude. It's got a bunch of ice. And anyway. Summer in the Antarctic. It says November through February. And that's winter in the northern hemisphere. So summer is when it's the warmest, and during those times the sun is up almost constantly. And now we're going to look at the climate of the pole summer by months. So their spring starts in September. September, October, November. And so this is at the end of their winter, and when the sea ice should be the greatest, at the thickest and the greatest extent, starting in September. Now I'm going to show you something else. That wasn't the one I want. This is the NASA World View. And yes, Forest Dweller was the first one to give me the link to NASA World View. I didn't start exploring it immediately when he did give me that link, and I did not remember that he was the first one to give me the link to NASA World View. So he was the first one, and I thank you, Forest Dweller, for that. But I did find it on another website too, and it's all over the internet. So this is looking at Antarctic. So if you want to change the view, we're looking at Antarctic right now. You just click up here. You click on the world and go to Antarctic. Now the reason okay, it's in the winter time down there, and so the sun isn't even shining. It's like dark. It's dark for several months down there. So in September, let's even go back to August. You'll see it blocks it out because it's dark down there, so there's no data. But so I'm looking at last year to see the sea ice from September of last year, and of course we're looking through the clouds. You have to look through the clouds, but you can see how far out the sea ice went, and then you can zoom in and see the consistency of it and different things. Here's the edge of it. So this was last year, and so what we're going to be doing is, as we come at the end of summer, coming into fall, we'll start looking at the Antarctic and see the sea ice extent, and see here is how far it went, because here's that peninsula. And right over here is that glacier, that Pine Island Glacier. That's melting so fast. So we can be watching that as well too. It's right over here in this area. So I thought that would interest people, that you can actually see it there. So I'm going to shut that one down. And I'll go ahead and show. Now this is from Arctic Sea Ice News and Analysis. This is, we've seen this website before. This is from yesterday. This is the Arctic. But if you keep clicking, you'll see the Antarctic. And this is the extent of where it is right now. That's just how far out it's frozen. And they count any kind of frozen, even if it's a little skim on the ice. They count that as frozen. So that's deceptive to think that that's solid. It's not solid. And here's the concentration. and here you can see the bigger picture. But they're in the middle of winter. Their sea ice is still building, and it's still getting colder. So the coldest month for them is July. Just like the hottest month for us is July for the northern hemisphere. So the coldest month for them is July. So it should keep on building through and then through July, August, September, and then it'll start decreasing. So by the time we're able to get back to the NASA World View in September, we'll see how concentrated it is and see how far out it went. So we'll keep an eye on that. But you can see the concentration is not that much, according to this picture. Here's another website where you can see the sea ice concentration. This is from the University of Bremen. Sea ice remote sensing. And this is part of the Copernicus imaging microwave system radiometer. Here's the North Pole, here's the South Pole, and I'll leave a link below to that, and you can see on the graph here like the concentration. And if you can't get the whole picture, you can just click on the image here. And here's the scale below. Like the concentration, like this green is like 50%, they say, around the edges. And then the yellow is 75%. So it's getting there. It's getting there. So it's just something we need to keep an eye on. So let's go back to our seasons. September, is this where we started? Yeah. September, where they're heading into their summer, it's between -55 to -62 Celsius, or -67 to -80 Fahrenheit. They have 34 hours of sunlight during September, but that's spread out. It's not 34 hours all at once. It's spread out as the Earth is tilting to get a little more sunlight. They might get an hour a day here and there. They have 12 snowy days, and precipitation is 0.1 millimeter or 0.004 inches. October, it warms up a little bit. Their maximum average is -48 to -54 Celsius, or -54 to -65 Fahrenheit. And they get 390 hours of sunshine during the sunrise, 17 snowy days, 0.1 millimeter of precipitation. November, it warms up a little bit more. Maximum average to minimum average, -37 and -40 Celsius, or -34 to -40 Fahrenheit. And they get 558 hours of sunlight, 17 snowy days. And it's dangerous in there in the summertime, because there's like almost no clouds, and the sun never sets during half the year. December, you can see for yourself. January and February, even during those days, the temperature is still way below zero. It's way below. And then winter, I think this is not correct. They said winter comes to Antarctica at March and lasts to October. I think they meant August, because they just put September up here as starting of the spring and summer. So fall is March through May, and then winter is June through August. So that's when it goes. Hi, this is Margo. I'm back. They crashed my computer, so we're continuing looking at the Antarctic. So I was just finishing up talking about the seasons in the Antarctic, and that July is the coldest month for them, and July and August are the coldest months, and then it starts warming up in September. That's what their seasons run. So we'll be watching the Antarctic if we're still here, if things don't fall apart, you know, at the end of the summer and all of that. So we'll be watching and seeing the climate melt, the ice melting down there. So now the next part I want to look at is buried volcanoes. Now here's an article from Live Science talking about buried volcanic vent heats up Antarctica's fastest melting glacier, and they're referring to the Pine Island Glacier here. And here's a picture from 2014 where they went on an expedition. There was a scientific expedition during which scientists discovered an active volcano heat source between the Pine Island ice shelf. So that was discovered back then, and so we've known about this. It's not new, but it means it's active and it's been warming up. So I'm going to leave this article below. There are other glaciers that have volcanoes going off. There are actually 138 glaciers in the Antarctic. On Wikipedia, here's a list of volcanoes in the Antarctica. It says a 2017 study claimed to have found 138 volcanoes, of which 91 were previously unknown. The unconfirmed volcanoes are not included in the table below. So, before they thought there were only about 100, but now they found 138. And also 91 were previously unknown. And so here's a whole list of here's the name, here's how their elevation in meters and feet, here's their coordinates, and this goes right over to you can get more detailed information when you click on the coordinates. Here's the last known eruption, and we're going to look at the Pine Island. Oh, Mount Erebus. Mount Erebus is the one I wanted to show you. And last known eruption is 2018 because it's erupting. It's active. It's active. It's been active this whole time. And so I'm going to show you some more information about that. And Mount Erebus is the second highest volcano in Antarctica. after Mount Sidley, and the southernmost active volcano on Earth. It's the sixth highest ultramountain on an island, with a summit elevation of 3,794 meters or 12,448 feet. It is located in New Zealand's Ross Dependency on Ross Island, which is also home to three inactive volcanoes, Mount Terror, Mount Bird, and Mount Terra Nova. The volcano has been active since about 1.3 million years ago and is the site of the Mount Erebus Volcano Observatory, run by the New Mexico Institute of Mining and Technology. So here's where it is. It's right down here. This is the Ross Sea. There's the Ross ice shelf. The Ross Sea is right down here. And so Mount Erebus is on an island right over there. So we're going to look at that in a second. Here's all about Mount Erebus, and they explored it with robots and things like that. Now, we're going to look at these images. They're really interesting. Here's the island that it's on, and it's right here. This is Ross Island. And this is Mount Erebus, and there's Mount Terror over here, and there's the other one. 12,448 feet. Let's go to the next picture. Here's a picture of the top of the volcano. Mount Erebus craters. This is a picture of the lava lake that's down in the center of Mount Erebus. It can be seen from satellite glowing. It's a satellite picture of Mount Erebus showing glow from its persistent lava lake. So it's got a lava lake that can be seen from outer space down in the center of that, and that's what's active and is giving off stuff all the time. And here it is, Mount Erebus in December of 1955. So I'm closing these out as I finish with them. Now I'm going to show you. We're going to get to cams in a minute, and we're going to bring all this together. I'm almost done. Here's another article from the Independent. Active volcano discovered beneath Antarctic ice sheet could be contributing to rapidly melting glacier. And they're referring to the volcano underneath the Pine Island Glacier. They found it in 2014. So there's that article. Now, here's something. I'll show you that in a minute. This is another website that talks about the Pine Island Glacier. Now, here's a really good map. This is where I got the map that I showed you earlier. It's a fast-flowing ice stream. Pine Island Glacier is one of the largest ice streams in Antarctica. Now let's hope this cooperates. I'm almost done. It flows together with Thwaites ice stream into the Amundsen Sea embayment in West Antarctica, and the two ice streams together drain about 5% of the Antarctic ice sheet. Pine Island Glacier flows at rates of up to 4,000 meters per year. It is of interest to scientists because it is changing rapidly. It is thinning, accelerating, and receding, all of which contribute directly to sea level, and its future under a warming climate is uncertain. Pine Island Glacier is buttressed by a large floating ice shelf, which helps to stabilize the glacier, but this ice shelf itself is thinning and recently calved a huge iceberg. And so that's what they're worried, that the shelf is going to be breaking off, and when that breaks off, it calves. Calving means it's breaking off, and if it breaks off, then that won't be holding back anything from and keeping that ice from just flowing into the ocean even faster. So this is a really good website. Here's a lot of data, a lot of information. I'm just going to go through this quickly. You get the idea: calving icebergs, this and that, current melting, thinning, and acceleration. Now this is a really good cartoon image of, here's the Pine Island Glacier. There's a floating ice shelf that comes out over the ocean. Here's the ocean, here's the continental shelf underneath, and the water comes in, and then it swirls around and mixes and comes back out. And so if this water is warmer than it's supposed to be, then normally, which it is because the ocean water is heating up, it comes in and it's mixing with that melting and everything, and so it's melting this ice shelf from underneath. And then there is this ice flow anyway from the glacier, and so what they're saying is if this ice shelf breaks off too much, it won't be holding that glacier and that flow back. So the glacier is thinning and receding. So I'll leave a link below to that. And Pine Island Glacier from Wikipedia, more of the same. The area drained by Pine Island Glacier comprises about 10% of the West Antarctic ice sheet. So it's quite a large amount that drains off. And it talks about the subglacial volcano, this and that. So that's a good article too. And then here's the last article I'm going to present, and then we'll get to CAMS and Climate Reanalyzer and bring all this together. This is from Daily Mail. Oh, it would crash. This scientist from the UK went with a team down to the Antarctic, and they figured out a way to image things underneath the ice, and they found vast canyons and mountain ranges twice the size. They don't want this information up, obviously. Twice the size of Ben Nevis had been discovered hidden beneath the South Pole. Ice penetrating radar was used to uncover the canyons. Anyway, I'll leave the link below. I just don't think I'm going to be able to present this article. But these canyons are important because as global warming comes along, then these ice rivers can just flow even faster. So this is brand new. This is brand new research, and so I'll leave a link below to that, and there are lots of articles about that. Now, let's get over here. This is Climate Reanalyzer. This is the temperature we're on today, Saturday, July 21st. And since we're looking at the Antarctic, we'll go ahead and get that view up. Here are the temperatures. And here's the two temperature anomaly. And you can see, and we've looked at this before, but now we know more of what we're looking at. Now, this is the South Pole, this is Antarctica, but it's flipped. Over here is the tail. Let's look at this image. You can see the orientation. Here's the tail. So here's West Antarctica. Over here is where the Pine Island Glacier is, that's heating up and melting so fast. Over here is where Mount Erebus is, with the Ross ice shelf and all of that. This is the eastern part of Antarctica. So the two temperature. Hi, this is Margo. I'm back again. They crashed my computer again. Hopefully we can get this finished up. So as I was showing everyone on Climate Reanalyzer from today, Saturday, July 21st, this is the 2-meter temperature anomaly. And on the Antarctic view, we can see that the ocean is about 20 degrees Celsius warmer than it normally is. And also on the east part up here, the northeast part of Antarctica, it's really warm like that too. Now, it's also warmer in the area where that Pine Island Glacier is. So, but it's cooler. It's cooler in the ocean around it. Now let's look at sea surface temperatures. So there's that. Sea surface temperature anomalies. So when it's warmer than it's supposed to be, that means that water coming up underneath that ice shelf is going to be helping to melt everything from underneath. So now we're going to finish up with CAMS, Copernicus Atmosphere Monitoring Service. We're looking at sulfur dioxide total column. This is measured in parts per million. We're looking down on the Arctic, and the orientation is back the way we normally see it, with the tail over here. So the west side is over here, the east side is over here. Here's the Ross Sea. And the data goes back to Tuesday the 17th through today the 21st. So we're going to run this movie, and what I'm particularly interested in is seeing the sulfur dioxide being released from the area where Mount Erebus is, and you will see it. It's going to show up in this cream colored, which is about 2 parts per million, between 2 and 5 parts per million down here. So it's right here, that little tippy tip, the island is right there, and that's where Mount Erebus is. So you can see that it's emitting, it's releasing sulfur dioxide in the atmosphere, and so that's a sign of, as we know, that's a sign of geologic activity. And we can also see sulfur dioxide moving over from the rest of the southern hemisphere, from all the volcanoes going off and everything. So that sulfur dioxide also is chewing up the ozone layer. There's a hole. The hole is getting worse. I thought getting worse. We'll look at that in a minute if they don't crash my computer. Here it is on the world view. the flat view. So just to show people what sulfur dioxide is doing. Now I'm gonna, while this movie loads, I'm gonna grab the map and pull it up, and if you look down to the left of my mouse, you see the cream colored plume coming out from down to the left. That's where Mount Erebus is releasing the sulfur dioxide. It's constantly releasing. So this is of concern, especially when you see that. I'm thinking that's just like more of all this stuff going on the Pacific plates that are moving. So we got a lot of stuff going on. We got a lot of activity going on. So let's close that. And now we're gonna, if they don't crash my computer, I'm gonna show you ozone over the South Pole. The data goes back to the 17th and it's through today. So you can see that this is 225. And let's run the movie. I should have gotten more panned out with this so that you could see the ozone thinning around the equator too, but I didn't. So it's loading up. I will do a climate cast in the next day or so, and we'll look at the methane. Okay. You can see the blue where it's moving around, and the green. The green is 250 to 275, and then this yellow-green is 300 Dobson units. Okay, you see it going into these darker blue. That's 200 Dobson units. So the ozone hole is thinning, and this is the actual data, and we can see that it's really thinning. Watch, here it is on the 20th and the 21st, and I'm thinking it's from all the sulfur dioxide from all the different volcanoes in the southern hemisphere that's just mixing in and is chewing up that ozone layer and spitting it out. So I'll show you one more thing. We'll change the area to South Pole. And you'll see a wider view of how thin that ozone is. See, there's the 225 all around the equator part. Look, northern Australia is caught up in that too. And let's run this movie. And then we'll wrap it up for today. I appreciate all my subscribers and all my viewers and everyone over on Facebook. And so just another announcement, we're going to have our next campfire chats with Margo on this Thursday, July 26th at 8 p.m. Eastern Time. I did an announcement on it yesterday. We're going to have new call-in numbers, and it's a whole new platform over on TalkShoe, and there's about 10 or 12 different countries that we'll have call-in numbers for. So I hope to see everyone on Thursday. Okay, there's the ozone, total column. And you see that blue, that hole is just staying right over here. on that left side. Now watch and we'll see it go to the blue, the darker blue. Here it comes. See? That's about the lowest I've seen it. And that's about the lowest. The lowest NASA saw it, I think, was about 175 when it was the worst. So there you have it, folks. My name's Margo. My website is margoshealingcorner.com. Until next time, everyone, get your spiritual houses in order. Time is short. Go in peace. God bless everyone. Good night.